I'm doing the screencast so that I can redo conceptual objective number 1. The 4 questions that were being asked were: what is the displacement, average velocity, final velocity, and average acceleration of this video. First, I will show the video. The toy car starts at 0 centimeters, travels across the table, and crosses the 50 centimeter mark. The first question being asked is: what is the total displacement of the toy car? Like I said, 0. This is 0, and it crosses this line, which is 50 centimeters. So the total displacement is 50 centimeters. And then I changed it to meters because velocity deals with meters and not centimeters, so I made it easier by dividing 50 centimeters by 100 centimeters, because that's how many centimeters are in 1 meter. That equals 0.5 meters. So the displacement is 0.5 meters. The second question being asked is: what is the average velocity? The average velocity is going to equal the change in position divided by the change in time, which is shown here. We know the change in position because we just found it. It's 0.5 meters. The change in time we don't know, but we can find that out by the video, because here is 0 seconds, and so the change in time is going to be the final time here minus the initial time here. The initial time, it can be found by how many frames were at this point divided by 240 frames per second. Well, as you can see, when the toy car starts, there is 0 frames divided by 240 is 0 seconds. So then the final time you can find by clicking to find when the toy car hits that line, which is there. And as you can see, there is 221 frames at this point. So we would use time final equals 221 frames times 1 second over 240 frames, which equals 0.9208 seconds. So then we can find the change in time. 0.9208 seconds minus 0 seconds equals 0.9208 seconds. So then our change in position, 0.5 meters, divided by a change in time, 0.9208 seconds equals 0.54 meters per second. And that is our average velocity. The next thing I have to find is final velocity. We just found average velocity, and average velocity equals half of final velocity minus initial velocity. We can assume that initial velocity is 0 because the toy car started at rest. And we have the average velocity, so we can plug those in, and 0.45 meters per second equals half times final velocity minus initial velocity, which is 0. So then we can just take out the initial velocity, and 0.54 meters per second equals half of final velocity. Multiply both sides by 2, and we get final velocity equals 1.08 meters per second. The last thing that we needed to find was average acceleration. Average acceleration equals change in velocity over change in time. Change of velocity equals velocity final minus velocity initial. We just found out that velocity final equals 1.08 meters per second, and we knew velocity initial was 0 meters per second. So subtract those two, we get 1.08 meters per second for our change in velocity, and we already knew change in time from above to be 0.9208 seconds down here. And when you divide those two, our average acceleration is 1.17 meters per second squared. Finally, the last thing that needed to be done in the screencast was show the motion of the car graphically using a velocity versus time graph explaining the relevant parts. So the y-axis is the velocity going up by 0.5 meters per second. Time is the horizontal axis going up by 0.5 seconds at a time. And then this is the graph. The velocity is a straight line because it starts at 0 and keeps increasing and increasing and increasing. And at 0.9208, the velocity is 1.08, and then as you can see, the slope is also constant, which shows the acceleration, and the slope is the acceleration, and the acceleration that I got was 1.17 meters per second squared, and that looks about right of what the slope of this graph is, because it almost goes through 0.5 and 0.5 at the same time, but not quite. It's just slightly steeper than a 1 meters per second slope. So that is the graph of the path of the toy car.